On to another observability clinic. Today's topic is a practical guide to SQL extensions with Dynatrace. It's about simplifying observability for your SQL query-based metrics with the new Dynatrace 2 extensions framework. And I couldn't have found a better person than somebody that is doing this on a day-to-day basis. Vagiz, thank you so much for being here. How are you doing?
I'm great. How are you, Andy?
Very good. I'm really excited because obviously databases are hugely important for any type of app out there. And we want to make sure we provide the right level of visibility and also the ease of observing, especially SQL statement performance, SQL query performance. And I know I want to shut up now because I want to hand it over to you because I know you've prepared a lot of things, some slides in the beginning, but then also demos and end-to-end demo to show how easy it is. Vagiz, with this, please take it away and show us a practical guide to SQL extensions with Dynatrace.
Yes, thank you, Andy. So let's start right away without further ado. We will begin with a bit of introduction of what we are going to talk about today. So first of all, we will quickly cover how Dynatrace currently monitors databases. We will learn how to build 2.0 SQL extensions, and we will talk about how to migrate from custom DB query to the 2.0 extensions. So small recap of how things were going before, how are they going now. Initially, Dynatrace was able to monitor databases from one agent side. So we are instrumenting an application, we are detecting calls to the databases, and we are able to tell which service calls which database, what statements are executed, we are able to detect their performance and so on. But that happens from the application side. And one agent must be able to instrument that application, which is really important for that to work. On the other hand, we are also able to do it from ActiveGate. That's a different approach. We are actually connecting from the ActiveGate to the remote database, and we are executing SQL queries on that database to get all kinds of data, performance data, job data, maybe even some business data, depending on your needs. And then that data gets ingested into Dynatrace by ActiveGate. Just a small detail, one agent is actually now capable of collecting certain data from certain databases. For example, SQL Server exposes some of its data through WMI protocol. So one agent can actually collect that thanks to the extensions and the data source. So what is SQL Data Source 2.0? Well, it's something that runs on ActiveGate. Specifically, if you have an ActiveGate and you have a Dynatrace environment, you have a target database, there is this module called Extension Execution Controller, which is responsible for executing all of the extensions. And imagine you have an Oracle extension in there deployed, you have a Postgres extension to monitor Postgres databases, and you developed your own custom extension. You deployed it to the environment, and you ask the environment to run this extension and monitor your target database. So this extension gets deployed on your ActiveGate. It then receives a JDBC, a JVM basically, Java virtual machine with the required driver to be able to connect to the target database and execute certain queries. Obviously, we get some data back from the database and we parse it within the extension itself. And then whatever we got, metrics or logs, they are ingested back into the Dynatrace environment. Some of the details about that is that this only works currently on ActiveGate. So that's something to keep in mind. We are connecting to all of the databases using JDBC. So that's how SQL Data Source works. Performance-wise, I wouldn't worry. We did some internal testing and we are able to run simultaneously hundreds of connections to SQL databases on a single small box, which is quite impressive performance-wise. And the impact on target database completely depends on what kind of queries you run. So that said, we already have some of the extensions for popular databases published on the hub. So you can already monitor some of the popular technologies, Oracle, SAP Hana, SQL Server, and many more actually. Postgres, DB2, MySQL, Snowflake, you name it. For most of the popular databases, we have an out-of-the-box monitoring. And the cool part is that you can download these extensions and see exactly what we did there, what we wrote, how it works. Small note about database app. I know that we just recently released an app Spotlight with UND, which talks about this database app. And this is a cool new app available in our platform, which allows you to have a single entrance point into your database monitoring and observability, and includes some cool features such as statement performance analysis, for example. Now, let's go to the meaty part of this recording, how to write your own SQL extension. So with the VS Code add-on, for which we already have some documentation and recordings, we are definitely going to rely on that. This add-on greatly streamlines the process of developing extensions, make it really easy. And we, as developers of the extensions inside Dynatrace, we use it day to day. So that's our main tool when it comes to extension development. And we know what pains are there, so we try to make it as easy as possible to use. And we use it ourselves. So it does some of the things such as schema validation, auto-completion, builds and signing, testing even, as of recently, and deployment, of course, to your environment. What is possible specifically in the SQL 2.0 data source? There are some certain things you can do which you couldn't do before. Of course, you can write your own queries similar to custom DB query. You can specify execution frequency, how often every query should be executed. But on top of that, you get generic topology. So now you can build your own generic topology entities and relationships between them based on the metrics and logs that you ingest with this extension. This is awesome because you can enable Davis to analyze that, build a relationship between a certain database or host failing and the query bringing some abnormal results. That's something we do in our out-of-the-box extensions as well. So that's a big new thing in the 2.0 SQL data source. Log ingestion as well. So you are not only limited to ingesting metrics, you can also ingest logs. And it can be anything, even queries themselves, like query text and execution plans, if you will. And a big part, of course, of the whole extension framework 2.0 release is the performance improvements. Previously, our extensions were Python-based mostly. And right now with the 2.0, we have dedicated data sources for every type of the extension, including SQL data source. And the improvements, the ability to execute things in parallel is great. So that's something which greatly benefits customers who have thousands of hosts, thousands of endpoints for databases that need to be monitored. So that's something to rely on and something to count on when you migrate to 2.0.
Vagiz, I just have a quick question before you go into the demo, just for clarification and also where I see this fit. So I think this allows me now to implement multiple use cases. One could be you have a database with business relevant data, and you can query the data out through an extension by simply specifying that SQL query to say, I don't know, number of orders, order totals, orders by product, right? If you have this information in a database, you can use the SQL extension to pull in this data, and then you get business metrics. That will be my first use case. Yeah, another use case, which I think you mentioned also, it's nice if your database, if you have many instances of databases, and those databases provide data in tables about maybe the database internals, database performance, something that we don't already cover out of the box. You can use this extension to say, I want to monitor all of these instances and I want to extract data from these databases because I know this database runtime provides certain data in their tables, like the $, the tables in Oracle, I assume, right? If something similar exists in other databases, then you can do this now as well. And this is really fascinating. And what I love here a lot is that you also talk about log ingestion and topology. So it's not just that we are ingesting the data and put it into another silo, but we're connecting it with our Smartscape. And this is phenomenal. Thank you. Yeah.
Yeah, so just to add a little bit to what you said, Andy, yes, business cases are actually, I would say, primary use cases for 2.0 SQL extensions when you need to monitor certain business data in certain instances of databases. That's a great use case. That's what we expect people to use SQL Datasource for. And of course, as you mentioned, additional complementary monitoring for what we already provide. So let's say you have an instance of Oracle and we don't provide something out of the box. We don't provide certain kind of monitoring. It's very easy to write an extension which will pull that kind of data, process it exactly as you wish, and ingest it into Dynatrace, and it will complement what we already collect for you. So that's a great use case as well.
Cool. I would say let's see it live, because I only believe it if I see it.
Well said. Yes, of course. Let's jump right into it. So with SQL Server Extension development, let me be very straightforward. It's exactly the same. It's very similar as every other extension. So we rely on VS Code environment. We rely on our add-on, and the process is very similar. So let's start from scratch. First of all, we ensure that we have Dynatrace Extensions add-on installed, this one. So that's basically all you need to make your environment in VS Code ready for development of the extensions. So once we have that, let me just create a new project. I will call it something like SQL Stats, and it's an empty folder. I will open it. And the first thing I will do is initialize the development environment for the extension. So the command is called Dynatrace Extensions Initialize Workspace. Let's do that. It offers me to choose a schema. I will choose a more or less recent one, 279. I know that it has all of the recent features for SQL Datasource specifically, and I can rely on it to build very modern, up-to-date extension. So let's do that. I already have it downloaded. If you don't, please click yes. I'm going to skip this step. Extension signing certificates, I already have them. I have them deployed on my environment. I have them deployed on my ActiveGate. That's the certificates I'm going to use to sign my extension, and the environment and ActiveGate are going to use them to verify that extension comes from a verified source. So that's why I'm using my existing ones. I will provide some links at the end of the presentation for documentation which describes how to generate these certificates and how to use them. And for SQL, we are using extension 2.0, so generic extension. And with that, we have our environment ready. Here is the basic carcass for the extension. It's a completely empty YAML file, as with every other 2.0 extension which we can develop with Dynatrace. Let's give it a nice name. So it won't be called MySQL Stats. That's the extension we are developing today. And how do we do that? How do we do that in Dynatrace, actually? It's an interesting question. From our perspective, the first thing we do is examining the data. So what is it we are working with? For today's demo, I've prepared a very simple table inside a SQL Server instance, which is deployed on a Windows host in AWS. And this table is called My Stats. It has just 3 columns. Let's open it. So approximately every minute or so, a new message is ingested. This message is actually generated by a SQL Server job, which runs on the SQL Server agent. And each message has a unique ID. It has a value which signifies whether it's a stat collection job or a failure or a successful execution, and a timestamp, a regular UTC timestamp. Now, with that table in place, we will want to collect 3 types of data today. First of all, we want current metric for every minute of execution. We want to see what is the current value which is reported by our SQL Server job. This is going to be our first metric. The second is a batch collection. So can we run some aggregation query, something to tell us, hey, what has been going on for the last hour, for example? How many executions did we get? What is the total of these executions? And lastly, the third query which we are going to write is a log ingestion query. Can we get this message, which can be arbitrarily long? Can we ingest it as a log instead of a metric? So let's try to write some SQL queries to see what we can get. So first of all, let's run a select on this database ordered from last to first. So we see that there are new rows every minute, more or less predictably. Every minute we get a new row. So for that, a good solution would be to write a small query, specifically with SQL Server syntax, which retrieves a single row for every minute, and we ensure that this row is the latest. Let's run it. Let's make sure it works. It does. So the most recent execution is right now, like 10 seconds ago, with value 1, which means success in my case, and some kind of unique message. What do we do next? We got to take that query and somehow convert it into metric. So let's do that. We go back to our extension. Let's copy the query. And let's give it a nice name. So the author will be me. The version is 001. So our first attempt, and we need to select a proper data source name. So every SQL data source starts with SQL, and using auto-completion provided by VS Code add-on, we can choose a data source specifically for SQL Server. For every database which we work with, we need to choose an appropriate data source. So if I start typing SQL, we can get a list of every single database we currently support. We are working on expanding the support to add additional drivers, but right now this is what we work with. And in my case, it's SQL Server. Similarly to other extensions, everything we do can be grouped into groups and subgroups. Today, we are not going to rely on subgroups. We don't have that many queries or different data to collect. We are just going to have 3 groups. And the first one is, let's call it latest data. Let's give it a nice feature set so that we can disable that whenever we don't need it. And the feature set is going to be called latest. I also want to specify the frequency. By default, every query is executed every minute. So I want to specify it explicitly so that whoever works with this code after me knows exactly what I wanted to do. So it wasn't unintentional, it was explicitly intentional. By default, we ingest metrics, but again, to be explicit, let's give it a proper name. We are ingesting metrics, not logs. And time to specify our query. Let's just paste it here. The semicolon at the end doesn't matter. Our extension data source automatically cuts it from the extension when it converts it to a JDBC statement to execute. So once the query is executed by our data source, this is what is going to get returned, a result set from a database. We would need to somehow parse it, and we know the names of the columns: timestamp, TMS, TMP, value, and a message. For the metric purposes, we only care about these 2 columns. Let's specify these metrics. First metric, and it's going to be the only one, actually, I will call it similarly to my extension, MySQL stats value. And the value will come from the column called value. It's important to use the same case. If we wanted to do it some more explicitly, it would be better to actually specify it here. So let's test if we can if we wrote a correct query. Yes, that works. And we can explicitly give it a different case. So something like that. Maybe it looks nicer. Let's copy that. Once again, paste it into our extension. And now we can use a lowercase identifier. So what is going to happen? This query is going to be executed by our data source every minute. The returned result set is going to be converted into a metric and ingested into our environment. What will happen if something is wrong with the query? It's a really important thing. Well, the way SQL data source works is that it's not going to crash. It's just going to warn you that, hey, either this specific query called latest data didn't return anything, it came back empty, or there was a problem. For example, we couldn't connect, we couldn't find a proper table, or we didn't have proper permissions. You are going to see this in your logs. First part done. Let's switch to the next one. The next one was getting some aggregated data, some more complex queries executed on this database. Let's run another query, which I have prepared. So this time we are getting data for an entire hour. For the purposes of the test, let's switch it to last 10 minutes because we might want to get this data more frequently. And let's give it a try. So what happens is that based on the MyStats table, it retrieves how many queries, how many rows were inserted by my job in the last 10 minutes, and what was the total value of all the status codes inserted with every row. So in this case, there are 10, sometimes this value can vary, it can be 8, it can be 12, depending on what was happening in SQL Server jobs. And this query gives us a nice statistic. So we might want to add some additional dimension. For example, we don't have a use case for dimensions here, but we might want to add it specifically for our extension to signify something. What if we run the same extension against different instances? Or maybe we want to mark this specific metric with a certain dimension just for purposes of further analysis. So let's do that. We will create another query. We will call it batch data. The feature set is going to be batch. Again, feature sets are something which will allow us to turn off unnecessary data collection. It's going to be executed every 10 minutes. Again, we are ingesting metrics. The query, we are copying it from our IDE. And now we have two columns returned from our result set. We convert them to metrics. I'm going to give this new metric a different name. Batch total. And the first value will be coming from the total column. And the other metric would be MySQL stats batch size. So there are two metrics now. A value for this column comes from the batch column. It's important to remember that you don't have to map every single column which is returned within the result set. You can choose just a subset of them. However, if you try to retrieve a value from a column which doesn't exist, the data source will complain. It will fail with this specific query while still successfully executing all the other ones which are correct.
Is there an option, sorry for a quick question, is there an option to specify default value in case the value doesn't return anything or the query doesn't return anything?
Absolutely, but it depends on the syntax of the database which you use. So in case of, for example, SQL Server, we could introduce a syntax which is called if null, which in case this data is empty, it will give us something else like a default value. for example.
Yeah, got it.
So we rely on SQL executed on database for this purpose. And let's just add a dimension for the demonstration purposes. We don't really have a dimension value in this table, but we want to specify a constant value just for the purpose of the demonstration. So I'm gonna give this name, give this dimension a name, which is stat name. And we can specify constant value dimensions with a const keyword. So in this case, the stat name for this metric is going to be batch, and a stat name for the previous metric can be latest. So alternatively, we could retrieve dimension name from the result set if we had something which could work well as a dimension.
Makes sense.
Yeah. All clear so far?
Yeah, all clear. It's very, very easy and straightforward. Yeah. All good. Thank you.
All right, perfect. So let's jump to another interesting implementation we can do in the SQL data source, log ingestion. First of all, let's see what are we going to ingest. I have another third query prepared for today. It works with the MyStats table as well, but this time we are retrieving two columns, which is a timestamp and the message. Let's execute it. And that's what we are getting. So for the last 5 minutes, and let's also order it from the latest to the earliest.
I think it's MS timestamp, not my timestamp. Yeah.
Oh, that's a good point. So
at least I contribute something to this.
That's right. So yeah, it's a good point. What we got is the 5 latest executions by the job inserted into this table. So we are specifically interested in the message this time. This message is unique for every single row, which makes it problematic to use it as a metric, to use it as a dimension, for example, because we will exceed the limit of possible dimension values. Imagine 3 months go by, you have thousands, millions of these different metrics with a dimension in each different dimension value create different time series in Dynatrace. We are going to hit a limit, and we don't even need a metric for this purpose. We are just interested in a message. Logs are perfect use case for this. So we are going to ingest this data as a log message with a specific timestamp. So let's do that. I'm copying the query which I wrote. By the way, this is a good example, Andy, which you talked about what happens if there is no message. If it's empty or it's null, we return a constant value. Hey, apparently there is no message here, but we want to return something so that we can later run a query in DQL or in classic Dynatrace log query language to, for example, see the messages which were returned with an error. Or in DQL, we can even count how many error messages did we get in the last hour. So let's write a query. Let's write a group for that. So log data, or maybe message data is a better name. And feature set is going to be messages. An interval every 5 minutes seems fine. We often choose 5-minute interval for log ingestion, just not to overwhelm the database, for example. So for many databases that we have, such as Oracle, SQL Server, Postgres, we collect, for example, query visibility data. What are the longest running queries? What are the top queries? We collect it every 5 minutes. So our internal testing shows that this kind of frequency seems to make most sense. But of course, it depends on your business case all the time. So very similarly to how we did it with other groups, we use our query, but this time we are ingesting logs instead of metrics. And this calls for a different attribute. We can rely on our VS Code add-on to tell us what we are missing, and it says that, hey, we are missing attributes field because it detects that we are trying to ingest logs. And so what I do is I specify the attribute field. And let me tell you what are the attributes which are a must, something you should always put into your extension. First of all, it's a content attributes. It's something which will represent the main content of the log message. In our case, this comes from the column called message. So this is exactly what we want to parse and what we want to search for. Now, the second the second attribute which we often specify in our extensions is called event group. So it's easy, it's kind of a notation which we use all the time. Imagine you have a lot of logs generated by your extension. How do you distinguish between them? So all of them come with the same extension name. So you can already filter down in DQL or in classic log query language by the extension name. But what if you want to distinguish between different log ingestion queries? So that's where event group comes useful. And I'm going to give it a name, a constant name, messages. So that I can filter down all of the queries. Finally, let's give another attribute. Let's add another attribute called timestamp, and the value for that is going to come from our TMSTP column. And with that, we should be done with all of the queries. So one additional thing which you could do is to specify the metrics right here, because then even though you don't collect any data yet, the Dynatrace environment will already be aware of what kind of metrics your extension provides. So we can give it just a bit of the metadata. So my values, good enough for me. The unit is count. Another metric which we collect, the other two, is the batch total and batch size. MySQL batch total. Similarly, let's give it a small metadata. Again, count seems to be a good unit for that. And very similarly, batch size. So this tells the environment right away what kind of data to expect from our extension, even before we ran a single query.
Well, once you're finished, I would like to ask one more thing on the log stuff. If you can scroll down to the log section. And this is, I think it makes a lot of sense, because when we are thinking about general log ingestion, when we are either having the one agent pull in logs, when we are ingesting logs from OpenTelemetry or anybody streaming logs to Dynatrace, typically a log is always, as you mentioned, has main content, the main content of the log. It has a data source. I guess that's the event group. Where does it really come from? And then a timestamp. Log lines always have timestamps. So I think this, for me, is a great mental connection from the use case that you are implementing here by extracting log information from a database versus how you normally do log ingestion, because every log line typically has a source, a main content, and a timestamp, and that's the attributes that you have here. So that makes a lot of sense for me.
Yeah, that's a good way to put it. I think one important detail we can add is that you don't have to specify timestamp here.
Okay.
In fact, if you omit it completely, Dynatrace will automatically mark your log line with a timestamp, which makes sense, so current timestamp. So we have a choice.
Yeah, cool.
Well, we have just completed our extension. That's it, really. That's all there is to it. And we could just take as many queries as we want, add them all here. It's important to remember that we can't have more than 10 groups, but each group can have up to 20 subgroups. So when you have 100 queries to execute, make sure to group them properly so that the data source doesn't complain. What it affects actually is the performance optimization. So that's why the grouping exists. Well, let's call it a done extension. Let's build it. Let's upload it to the tenant. Let's deploy it to our ActiveGate, and let's see it collecting and retrieving data for us. So I'm using VS Code add-on again for all of this. I'm asking it to build my extension. Thank you very much. It's done. It's signed. I would like to upload it, of course, to my tenant. And it's already uploaded, and I want to activate the latest version, and it's done. And now if I click this button, I will be navigated to my tenant where the extension is deployed. Here it is. Very easy process. Of course, I'm already connected to a proper Dynatrace environment. If you take a look at the observability clinic for VS Code extension, you will see how to connect your Dynatrace environment to your VS Code. And that, of course, simplifies the whole process. But in our case, all of that is already configured. Certificates are deployed, and extension is now on our environment. Perfect. Let's connect it to a real database. I already have an ActiveGate group ready to execute this extension. I'm adding a SQL Server endpoint because our extension works specifically with SQL Server. I have the connection data ready right here. So this one runs on AWS instance with a default port, and instance name is actually here. Yeah. So we can't really put instance name into the host. Database name is master in our case. We are using basic authentication, and we are using super user. It's a demo setup, so nothing to worry about. We don't need custom certificates.
Is the port really one? Just double checking.
Yeah, no, it's not. Thanks for noticing that. If you don't specify a port, the SQL Server data source will automatically choose a sensible default, or sometimes some databases can use dynamic port values and map you to a proper port. So let's omit it so that the database can decide for itself. Next step, we want to collect all of these data, all of these metrics. Notice how the feature set with messages has 0 metrics, which is precisely how many metrics it has, but instead it reports logs. Currently, we don't show how many different logs your specific feature set ingests. So this number only represents metrics. Let's give it a description, test 1, and activate it. So what happens now is that the extension is being deployed to every ActiveGate which is supposed to run it. In this case, single ActiveGate is going to be selected. The extension archive, which was just deployed to the environment by our VS Code add-on, will be distributed. Usually it takes 2 to 5 minutes for that to happen. Once it is there, the monitoring configuration, which we have just specified right here, will be activated on that specific ActiveGate, and the data collection will start. All in all, it takes somewhere in between 5 to 10 minutes to start getting the data which we want. One small detail, how does the interval work? So once your extension is deployed first time, all of these queries are going to be executed. It's not going to wait 10 minutes. And then they are executed at predefined intervals. We don't support cron syntax yet, although we know people ask about it maybe soon in the future. But the execution starts once the monitoring configuration is activated on the ActiveGate.
Hey, as we are waiting, just one more question. If you go back, please, to your config file. That's possible if you scroll up to the metric here. That's already good. What if the SQL query returns more than one record, or is the SQL query supposed to return only one record?
Excellent question. Right here, the SQL query returns exactly one record, and we are counting on it. We are actually requiring it. But in this case, the SQL query is going to return 10 records. Well, actually one record as well, because it's an aggregated query.
Mm-hmm.
What will happen if your SQL query returns multiple records is that every single row in the result set is going to be converted into
A data point.
a data point, exactly. Yeah. A distinct data point with its own dimension. It's important to make sure that it's not the same row 10 times, because it makes no sense. Why would we ingest 10 data points with the same value and dimensions? So usually we use columns, different column values as a dimension value to distinguish between the data points, and then a certain column as a value itself, because metric can only have one value, but a lot of dimensions. So that's what happens. Also, while it's being deployed to ActiveGate, a couple things about what you can do here. You can also build a dashboard on your environment. You can export it as a JSON. You can put it right here into this folder, and then the extension YAML allows you to specify a path to this exported dashboard. So if you built a dashboard for your business data, it can be very useful to just package it up, put it into extension, and then it can be redistributed if you deploy it to another environment. So no need to copy it manually. Another thing, if you configure alerts, you can do the same thing. So give a path to the JSON specification of an alert, and this alert gets deployed and activated together with the extension when it's activated on your environment. And of course, a couple of great features that were added to all 2.0 extensions. We can build topologies, so we can specify types. You can see how much is done for me by the VS Code add-on. So in this case, if I want to create a new entity based on the metrics I collect, if I had something like a column which specifies a host name, for example, I could use that to create a specific entity which represents maybe an instance of the database. And those business data is associated with a specific instance. More on that in our documentation. Again, I will give a link at the end of the presentation, how to build topology, and also screens. We have unified analysis screens. You can build your own entity screens, your own charts, links between entities, awesome stuff. You can build very complex extensions, even more complex than what we do here in our extensions team.
Exactly, and that's just as a reminder, all of the additional links we have to other clinics, to other documentation that cover everything that extensions can do, you will find them in the description of this video.
Yes. So let's check on our extension. Let's check on our deployment. Something could be wrong. Let's check. Well, it's actually a normal behavior. So first time when extension is deployed, that often confuses people. It often confuses me, to be perfectly frank. When you didn't yet fetch the archive to ActiveGate, when it didn't yet run, it's in the error state, and it's perfectly fine. Just give it a few minutes. It will start monitoring. Once it confirms a couple of data pools that everything is fine, you will get the OK status, and the message of the error will change to OK. So it's perfectly fine.
It's also nice what it just showed, that obviously every single execution of an extension is stored in Grail again as an event, so you can actually query the results and the execution, the state of every configuration of every extension.
Yes, yes, Andy, and I will talk about it at the end of the presentation. Make sure to enable logs on your tenant, because that's how we get self-monitoring data from every 2.0 extensions. That's how I'm able to see what is going on. I can see that the pooling of my instance was successful. I can see all the warnings, errors. So that's really important. And small point about automating of creation of instances. Here is the JSON which actually gets added as a monitoring configuration. Dynatrace has a REST API for working with extension monitoring configuration. You can build this yourself out of a CSV, which you have with thousands of endpoints, and create this monitoring configurations automatically instead of configuring everything manually.
Yeah, cool.
Let's check the data. I hope it's there. So our metrics are called MySQL stats. Perfect. Looks like the data is being ingested. So specifically 3 metrics. We can see them in the Data Explorer. Let's check what's going on.
Cool.
All right, we got several data points already, all of the same value. So means my job executions on the SQL Server side were successful. Perfect. Let's check just one more metric to see what's going on. Yep, it is executed every 10 minutes. So that's perfectly expected that it was executed once, and the next data point will come in a few minutes. And let's see, let's verify that our log ingestion works as well, because we are ingesting some logs every 5 minutes. So what we need to do is to filter down by the event group and by extension name. So filter, filter matches value is what we want. And we need specifically DT extension name. And in our case, the extension name, let's verify it. It's custom MySQL stats. Let's check if that works. Oh yeah, perfect. Some data is there. Let's add another filter just in case, because if we have multiple queries, we want to filter down by event group. And in this case, my event group is called messages. Let's see if that works. Perfect. Of course, we would want to also specify that we want data for the last 5 minutes, so that we don't get like data for entire time period. But it's up to you. It depends on your business case, of course. So here we can see that we correctly retrieved the content. Everything we got from the database using our SQL extension is now ingested as logs into our environment. We can work with it, we can query it, we can aggregate it with SQL, we can compute all kinds of insights. Perfect for our data lake, basically.
Yeah. That's awesome. And I know you're showing your logs and events, kind of our V2 UI, because obviously this data is in Grail. So if you're building new notebooks, new dashboards, you can use this data also for your automation workflows. You can use this data anywhere. So that's awesome. Yeah.
I do use Gen 2 UI a lot to ensure that the extensions we build work both for
both sides,
managed
for
customers
and
exactly.
Yeah, that was my next question. So everything you showed today basically works for both managed as well as SaaS.
Exactly. So our extensions, our SQL extensions, work exactly same on managed environments and on SaaS platform. So you can see that I got the same results. The query has already executed twice, so we get twice as much data, but it works both in 3rd gen and in 2nd gen.
Cool. Awesome.
So let's switch back to the presentation. We just saw an extension being built from scratch.
Yeah.
A little bit about converting and migration from custom DB query, because we know that a lot of our customers use custom DB query to collect business data or additional data for performance analysis or some infrastructure monitoring kind of data. How do we migrate? Well, first of all, most of the things, like 99% of things which are possible in custom DB query, you can do in 2.0 SQL extensions. So don't be afraid to migrate. We just saw how easy it is to create a 2.0 extension. We can do all of that. Everything we are able to do in the custom DB query, we can do in 2.0. And one micro announcement. Our team is currently working on a 3rd gen app for a platform, which will simplify the creation of such 2.0 extensions in platform UI. So instead of having to install VS Code and work with add-on, work with YAML, you would be able to potentially do that directly in an app.
Nice.
So you input your queries, you say what dimensions you want, you get the data, you get a built and signed or maybe even deployed zip archive. So we are currently working on that, prototyping. We will see where it gets us, but something to look forward to. Troubleshooting, very important section. A lot of things can go wrong when we connect to remote data sources. In this case, make sure that you have logs enabled on your environment. As we saw, this is where all of the self-monitoring data is in. We can check what is wrong with specific monitoring configuration. You can also retrieve this log directly from the ActiveGate by going to this or this path. Those are defaults. And inside the support archive, if you prefer to use support archive, you can find the actual logs of the extension in this path. So it's similar both on Windows and on Linux. Please look for fast check and for Dynatrace source SQL files specifically. This is where you will find the most detailed stack traces and everything which went wrong if something is not correct. As I promised at the end of the presentation, some of the links which are also going to be in the description to this video. Lifecycle of 2.0 extensions. Make sure to check out SQL Datasource documentation. This is where everything I talked about today is described, how to write this YAML, how to work with it. And make sure to check out Dynatrace Extension 2.0 Observability Clinic if you didn't already, because that's a really good introduction into the whole thing of building 2.0 extensions with VS Code.
Yeah. Thank you so much, Vagiz. It's amazing. I always say when I do these clinics, I learn a lot, and typically I also ask a lot, but today I was rather silent because there was just, it was very clearly presented, really nicely done, end to end, was perfect.
Thank you.
Folks,
I'm glad to hear that.
Yeah, no, really, it was a pleasure. And I know you said there's so much more you can do. I would like to have you back at some point where we can do maybe some tips and tricks and some use cases, like a specific additional use case on what type of business data, for instance, in a database, and then bring it into Dynatrace using the SQL extension. But for today, that's it. Folks, if you have any questions, either leave a comment on the video or the community. I would say the community is a good place to start as well.
Absolutely. Thank you for having me, Andy.
Pleasure.
And good luck, everyone, with building your 2.0 SQL extensions.
Bye-bye.
Cheers.